Alright, so today what we're going to do is we're going to multiply fractions by using the distributive property, and we're going to combine that with using models, and then of course the standard algorithm. So in the first example, we're going to show what is 1/2 of a fourth. So you have a box, right? And it's divided up into 4 parts, and one of the parts is filled in. So that's 1/4. And then we want to find half of that, right? So we're going to break this up in half, and then we're going to shade in half. Now there's a question. How many parts are there in one whole? So how many parts are there now in this whole region? Lante?
8.
There's now 8. So we know that our answer has to have an 8 in the denominator. Out of all the parts that are shaded, how many have been shaded twice? Come on. 2 parts. One part, 1 shading. Big parts, 1 shading. This part has how many shadings? So how many parts is this? How many parts is this? 1. Okay. So when you look at part 3, the part that is shaded for both fractions represents a half of this fourth, which gives you 1/8. Now here are the steps at the bottom for multiplying fractions. Multiply the numerators. You want to fill that in for step 1. At the bottom of the page. Multiply the denominators. Step 2. And then step 3 is my favorite part. That's where you simplify your answer. Now if you remember, simplifying means that the terms, the numerator and the denominator, are as low as you can get. Is the answer simplified? If so, why? Zari.
It's simplified because you cannot get any other number that is into 1/8.
What do you think about that, Dave?
I think it's correct because the only factor is like 1.
So what Azaria said was that there are no other factors that can go into 1 and 8. That was what she said. What do you think about that? There's something about what she said that's off.
There is other factors that go into 8, but in 1/8, there's only factors that go into 1.
Almost. Giovanni.
Already said that there's only factors that go into 1/8, but that's true. But there are different factors that go into 1.
Because what's the only factor that can go into 1 and 8? 1. So, it's already simplified because the only factor that can come in is 1. What's the other reason why you can't simplify this any further? Marquise.
Because you know what is the numerator that you can simplify it any further.
Perfect. This has a special name. What is it called?
Unit fraction.
It's a unit fraction. All right, let's turn to the second page. So here's the guided practice. We're going to multiply the fractions using models and the standard algorithm. So problems 1 and 2 are repeat of what we just worked on the first page. So take 2 minutes to finish problems 1 and 2. Make sure to do the appropriate shading in. I see Ariel's got it. So is Javon. Okay, should we shade those parts? Yes. No, we must start with the answer and then do the shading. We start with the shading first to get to the answer. So this is 1/2 times 3/5. It's really 1/2 of 3/5. So the first shading we do is 3/5. 3/5 are here. 3 of them are going to shade. Here's your 3/5. Now we want 1/2 of them. So we're going to shade it differently. So these are your halves. Now you check to see how many total pieces you have. There's your 10. And out of the 10 total pieces, how many you shade them twice? And there's your number. Alright, raise a thumb if you're almost done or you're done. Okay, so see a couple of interesting things. Alright. Samara. Tell us how we would solve number 1.
First, you have to multiply. First, you have to multiply 1 times 3, and that would be, and then you have to multiply 2 times 5.
Okay, so she knows the standard algorithm. Multiply the numerators, 1 times 3 gives you 3, multiply the denominators, 2 times 5 gives you 10. But then here's what I noticed that Samara did. She just went ahead and she shaded in 3/10. Does the shading match the math? That's the question. Eliza. Louder. Why not? That's right. We have to show what 1/2 of 3/5 is. So now, Zaria, 1/2 of 3/5. What do we start with?
So first you start off with the column. So first you have 5 columns.
So here's your 5 columns.
So you only shade 3 in, 3 columns in.
So 1, 2, 3, 4, 5. See the fifths? We want 1, 2, 3 of them, right? So we're going to shade in 3 of them. And then, Zaria?
And then after that, it's broken into half. So 1/2 would be the bottom of the top.
Okay, you see the halves? Then we're going to shade in half. Okay, and then?
And then you see how many parts are shaded twice, and that will be 3. Wait, you have 10 parts in all, will be your denominator. And then you see how much parts are shaded twice, and that will be 3, which will be your numerator.
Got it. So now the math shows the answer, instead of taking the answer and then just filling it in. Got it? Okay, good. What about 3/4 of 4/5? What's the answer to that?
The answer is 4/20, but when you take it to the simplest.
What's the first answer we get?
The first answer we get is 4/20.
3/4 of 4/5.
Oh, we have to multiply the numerator.
Which gives you?
Well,
And the denominator?
20.
Okay. Did you simplify?
Yes. If you simplify, you would have to simplify twice. So it would come to 3/5, but
What did you use to simplify with?
I divided by 2, which got me 6 and 6/10. And then I knew that I could go lower because 10 couldn't be divided by 2 and so can 6. So I divided by 2 again, and I got 3/5.
Excellent. Yes.
I agree with what JL said, but instead of dividing it by 2, you could also just divide it by 4, so you only have to do one of those steps because 12 goes into 4 3 times, and 20 goes into 4.
Good, so he made the connection. If you divide by 2 twice, it's the same as dividing by 4 once. Let's get to problem number 4. Because that's what the lesson really is. And problem number 4 shows this. 2 1/2 times 3 1/3. And then I wrote that it equals 2 plus 1/2 times 3 plus 1/3. So we're going to use something called the distributive property. And the distributive property states that you can literally just like distribute the numbers around. You're going to multiply, but kind of just spreading around. So I'm going to use 2 different colors of ink so that you can see exactly what we're going to be spreading around. We got these whole numbers, 2 and 3. We got the fractions 1/2 and 1/3. I'm going to take the 2. I'm going to take the 2 and spread it around through multiplication. So I'm going to multiply the 2 times the 3, and then the 2 times 1/3. So I'm going to write that here. 2 times 3, 2 times 1/3. So you can write that down. Then the second set of multiplication is I'm going to take the half, I'm going to multiply that by the 3, and the half times the 1/3. So, yes,
I'm confused.
about?
What you said from when you started at multiplying the half,
Mm-hmm.
I got confused when it started right there.
All right. When we use the distributive property, it's a way of making the math easier to understand. It takes more steps, but it breaks them down into simpler steps. So, rather than trying to multiply 2 1/2 times 3 1/3, I separate the 2 1/2 into 2 parts, and I separate the 3 1/3 into 2 parts. And then I just multiply those parts separately. So I take the 2, I multiply by 3, that gives me 6. I take the 2, I multiply by a third, that gives me 2/3. Now I have to deal with the half. I take the 1/2, I multiply by 3, it gives me 3/2. And then I take the 1/2 and I multiply by 1/3, and that gives me 1/6. Now these are all partial products. I have to add them back. Yes.
How come we didn't simplify the 3 halves?
I didn't get to that yet. I didn't get to that. So now I'm going to add all of these parts up. Clearly we need a common denominator first. What would that be? What's the matter? 6. Do we change the whole number? Do we change the 2/3? So what is the new fraction now? 6 is in the denominator. 4. If you change the denominator by something, you have to do the same thing to the numerator. Elise. 4 6. We multiply top and bottom by 2. So what does 3/2 become? Like this part is the easy part.
9/6.
9/6. And does the 1/6 change?
No.
No, it's already there. Take 10 seconds just to add these parts up. What do we get? What do you get? 3 2/6? But I got this 6 whole number.
Yes, 6, and the answer is 6, and 2, 6, and we have to simplify it.
So let's see. 4 plus 9 is 13 plus 1 is 14. So I got 6 and 14/6. So he says that 6 and 14/6 is the same as 3 and 2/6. Any thoughts? Giovanni? Huh? Good. So the 6 wholes couldn't have gone down to that. But the 14/6 needed to be simplified. So 14/6 is the same as 2 and 2/6. 6 goes into 14 twice, and there's 2 left over. Now we're simplifying. So are we done, Deja? Take it to the last step. Yeah. You get 8 1/3. All right. Turn to the next page. Look at problem 9. A recipe calls for 2 1/5 cup of sugar. How much sugar would you use if you wanted to make 3 1/4 of the recipe? So we got 4 operations: addition, subtraction, multiplication, and division. This is clearly a what problem?
Division.
She says it's a division problem. Do we agree? Samara? It's a multiplication problem. Why?
If you wanted to make 3 1/4 of the recipe, not take it away.
Right. One recipe takes 2 1/5 cup of sugar. We need 3 recipes of that plus another 1/4 of it. So we can take 2 1/5 and add it 3 1/4 times, which is a little challenging. Or we can just multiply. Okay, we gotta separate this out. So 2 1/5 becomes 2 plus 1/5 times 3 plus 1/4. Using the distributive property, which parts are we multiplying together? Zara.
First you're going to multiply 2 times 3. And then you're going to multiply 2 times 1/4.
So she did this multiplication first. And then
And then after that, you're going to multiply 1/5 times,
I'll draw the arrows.
1/5 times 3, and then you're going to do 1/5 multiplied by 1/5.
Take 30 seconds to find these partial products. All right, what are the partial products? Come on.
2 times 3 is 6. 2 times 1 is 4. 1/4 times 3 is 3/5. And 1/4 times 1 is 6.
And we got to put these together. What's a common, yes? Yeah. Thank you. I'm glad you caught that. So where did the 1/4 times 1/4 came from? JF.
The 1/4 times 1/4 actually came from when you when you take apart the 2/4, you get 1/4 and 1/4, so you decide to multiply.
Well, it's actually 1/5 times 1/4.
Or it's actually 1/20.
Always important to check for errors along the way. So what's the common denominator here? Avante. 20. Does the 6 change?
No.
Okay. Ariel, what does the 2/4 become? Thank you. Love the mental math. What does the 3/5 become? Giovanni.
12.
Thank you. And what about the 1/20th? Stays the same. Take 10 seconds to add that up. Where's your final answer? Well, the 23/20th is 1 3/20, but there's still the 6. All right, what's our final answer, Adasia?
6 and 23, 20. 7 and 3/20.
Thank you. Who can simplify that? Ariel.
Can't see.
Why not?
Because it's not a common denominator that can go into 3 and 20.
That's not the reason. She says there's not a common denominator that can go into 3 and 20. That's not the reason.
I think it's because there's not a number that can go between 7 and 3.
She said there's not a number that can go into 7 and 3 at the same time. What do we think about that, Adasia?
I just use her because we are simplifying 3 and 20th, and we cannot simplify 2 to 3 20th because there's no number that will go in into 3 or 20.
She says there's no number that would go in evenly into 3 or 20. Are we brain matching that?
Yes.
We are?
Yes.
You have a question about that? I'm not quite sure about that reason.
Disagree with Samara because you're not supposed to simplify the whole number.
There you go. 7 is just 7. So we're not going to simplify that. But we're looking at the fractional part, the 3/20ths. And Adasia said that there's nothing that can go in evenly. You said there's nothing that can go evenly into 3 and 20. Marquise.
Because the only number that could go into both of them is 1.
That's
You
the,
don't use 1 to simplify.
there it is. The only number that can go in evenly into 3 and 20 is 1. And because that's the case, it's already simplified. Can't go any further. Okay, turn to the next page. I want you to work on problem 10. That's a stretching problem. 2 times 3 3/5. I'll give you 2 minutes. Don't forget to simplify. Yes. This problem is different because we have 2. We got 1 on some. So this becomes 2 times 1 plus 6 plus 3/5. And it's going to do that multiplication. We can't actually. We're going to take this 2 and square it out. Okay? So instead of having 4 multiplication step, which is 2 times 3. So I saw a couple of interesting responses. I'm going to put up 2 things that I saw. Which one is the answer? So the problem was this. 2 times 3 3/5, right? Which was the answer? And then we're going to talk about the other one. Where was the mistake? What's the answer, Giovanni? The answer is 7 1/5. You did the repeated addition, right? You did 3 3/5 plus 3 3/5, which gave you 6 and 6/5. Right? I thought I saw the repeated addition. But which is the answer though? It's the 7 and the 1/5. Why? Why? There you go. You have to simplify this. This part was improper. So you have to simplify it down to here. Okay. So Avante needs to know about this 6/5. How do we go from here to here?
Because 6/5 is more than a whole. So we add 5 going to 6 once, then we add 6 plus 1 is 7. And what's remaining is 1.
There it is. Got it. Question?
Why are they like the same? Aren't they both right?
She says, are they both right? Do you mean, are they both the same value? Are they both the same value?
Yeah.
Yes or no?
Yeah.
Yes. But there's a proper way to write it. Yeah. I'm going to talk to you for that in a minute, okay? Yes. So if the directions say to simplify, which answer would you put? Good. And if it doesn't say to simplify, which answer would you put? Either one. Yes. Either one is fine. If the directions tell you to simplify, you must simplify. Alright, turn to your exit.